We'll wait for 5 minutes.
Yeah.
Do you have the AIS Instagram up?
Huh?
Do you have the AIS Instagram up?
At the very end. Wait, oh no, I don't have that.
You don't have it on your phone?
No.
We are at TI Auditorium for you for game night. Are you on your way? Or are you on your way? For sure. No, because the messenger bag will fit. I do that. Feel free to sit anywhere. Good. Hi, Doctor. I wanted it earlier, but like I thought it was at 7. You say it's fine. I don't know. It's not. It's about. It's at the max. That's it. It's not easy. We've already got. We'll get you one. Give me a word. We can give you flags. Hey, what's poppin', everybody? Thank you for it's a camera. Oh, can they hear us? Oh shit! Hey, everybody! This is Biggie, the AIM director. We're waiting on for some professors to come through. If you feel the filter, tell your friends. Post on Instagram, like, share, and subscribe. It's a mood. Stop.
Yeah, we're not recording. But it's like so weird. You did. So yeah, I made that my name. It looks really good. I thought it was yeah. It's like great because we had chalk we have a lot of I think it's just more like I try to host meetings. We try to bring like speakers. Figure out like I
Well, we could. I don't have a Red Bull, bro.
I'm gonna cancel the music. Actually, hold on. Yeah, maybe cancel the music. Switch here. So just use this to click, and then this is it.
Okay, that's fine.
Yeah.
Okay. Okay. Thank you, everybody, for showing up tonight. I really appreciate it. We are, this is the AIM Showcase night. We are a subsidiary of AIS, and that's our wonderful president, Sajeev. Everybody, people have a round of applause. Okay, so today I am super excited to present 4 exemplary teams on their projects in different aspects of machine learning, all run on the cloud, because that's the greatest thing in the world, right? Everybody's talking about AWS, Azure, and all that crap. But here today, we have people who've never experienced the cloud, and people who are brand new to machine learning, get into machine learning, get into the cloud, and run machine learning models with their mentors. So, today's AIM Showcase night, I'm going to click the next slide. Okay, so today's agenda, opening remarks around 5 minutes. I am not timing myself. And then presentations, each presentation is about like 10 minutes. There's 4 teams. That is going to be changed when we get more teams. So please apply. Thank you very much. And closing remarks for 5 minutes. It's not going to go, hopefully the presentations don't go 75 minutes, but we'll see. Oh, wrong keyboard. So opening remarks, I kind of gave them, but my name is Viggy. I'm the AIM director. That's Sajeev, the president. I'll introduce the mentors, the judges that are here, and some professors who just came randomly, so we're going to call them out. Just what's the point, And so what is AIM? So AIM is a semester-long mentorship program meant for undergrad and graduate students who are interested in getting into AI and machine learning, and we provide them with experienced mentors who are in grad school, have machine learning projects, or have been part of the AIM program to basically lead a group of students into a machine learning project. Before, it used to be very simple and like, oh, we're running things on Colab. But this year, we decided to kick it up a notch and run things on cloud, so people are getting charged. So that's great. But essentially, we're trying to get you industry-level experience in the cloud, and that's because these projects that you use today and you see, you can test some of them. And then on top of that, these are great resume boosters for people looking for that. And past 3 years, I was like, hey, is AI machine learning kind of for me or not? Do I like cybersecurity instead? Come back, right? So again, one of the benefits, build your resume, build ML ops and applied ML in the cloud. And the goal is to have not a finished project at all times, because machine learning is an iterative process. But present your project in front of other professionals like we have here, and get practical feedback on how you improve your project, or get feedback on what you can do for the future, and basically potentially new job offers if you're into that. And continue your journey, and whether it be in academia or industry, come to academia. Okay. So introductions. Can I get Ryan Sharp and all the other mentors here? Everyone, come up. Can I get a round of applause for these people putting in hours? So I don't really do shit. These guys are the people who are actually leading the teams. That's just friends. These are people who are, searching on Google, helping them tirelessly for the last few weeks. I just want to recognize their time, effort, and everything they've been doing. So can you give like a quick intro about yourself, Ryan?
Hello, everybody. I'm Ryan. I am a junior studying data science here at UTD. And last fall, I was a mentee. And then this spring, I applied for this program a second time to be a mentee again. And I was given the opportunity to be a mentor. And I was so excited that I immediately accepted the opportunity. And I'm so glad that I did because it has been so much fun. Thank you.
Hello everyone, I'm a grad student here, CS, majoring, focusing on intelligent systems track. So this is the first club experience I have in UTD, where I get to interact with people from different schools, like undergrad. And yeah, this was a good learning experience for me. I get to learn with them. And yeah, thank you.
Yep. Wrong.
Oh, okay.
Are you good?
I'm a junior in computer science. I'm a mentor. Last semester, I was a mentor. I did a lot of stuff. This time was a little more than was before. I think it was 5 weeks. Now it's 10 weeks, and we did like 2 projects, and we learned new stuff like semantic search and NLP stuff.
You'll find out during his presentation.
Yeah.
And let's go.
Hello everyone, my name is Nachiket. I am a grad student majoring in computer engineering. So I had some experience with AI, but cloud and deployment, everything was a very new aspect. So it was fun learning how to tackle problems, how to explain things, everything. It was fun overall.
Thank you. And my name is Viggy. I'm a poster child for this. I'm a senior computer science, going to do my fast track. So not much about me, but it's more about the mentees and the mentors actually doing the work. So let's go on to introductions. Could I get the judges and any professors that are sitting to come up, please? Yeah. Sorry to get you. You don't want to get up? No. But so we can get you on camera. We want to remember this moment, so I brought my iPad here, so everybody's on recording. Thank you. Come on, Dr. Wilson. We're putting you on the spot. We love your monkey lectures. We need you. If you ever take him, he takes advanced algos, data structures, and what other courses do you teach?
Discrete math.
Yeah. So you can start from whatever direction. Dr. DeGroot, come on.
I'm just gonna sit.
Okay, I'll do. I guess Dr. DeGroot can introduce himself from his seat then.
No, I wanted to sit this out.
Oh, I mean, we're just having you introduce yourself so students know what the professor.
Relatively new here, 3.5 years, I think. I really love UTD. I think this is a great school. And this is certainly a great department. You guys are awesome.
Thank you. Just a brief introduction by myself.
I'm Elmer Salazar. I teach mainly programming languages and operating systems, and that's me.
That's all. Thank you.
And I'm James Wilson. I teach the discrete math courses and algorithms and atomic theory.
Gopal Gupta, Professor of Computer Science, and I teach computational logic and do research in AI.
Hello everyone, this is Shambhavi, and I'm currently pursuing my master's in computer science. Prior to this, I was working as a data scientist back in India, and I think that is what motivated me to come here and study more. And I'll be joining as a data science intern at Salesforce this summer. So I'm looking forward to that as well. And all the best to all the teams. I'm looking forward to all the presentations.
Thank you.
I'm Brian. I was the founder of the AIS back in 2016. I left a year later and started a company called Survivor. We suffered for 5 years and eventually grew to 10 states, from cities to universities to the Department of Homeland Security. And we got acquired this past August. And along the way, I've got to watch this organization grow from when we first started. I'm so proud of the leadership and the community as well. We wouldn't be around here if it weren't for y'all. So really happy to be back, and best of luck to the teams today. Not that you need it, but really proud to see everything that's been going on. And again, kudos to the leadership team for making it happen.
Yeah, thank you. So kind of like the format, just so some of the judges know and like everybody knows. So basically, teams are going to present 10 to 15 minutes at the worst. There might be demos, so you might want to get your phones ready to like scan a QR code or something. And the judges here, not judges, are more like giving input on like what the project is, asking questions and being curious about any of the projects that we have, and giving potential improvements to continue the projects if we do that, and more. So, okay, wrong computer again. Okay, so I just did that. Yeah, so 10 to 12 minutes, and after each presentation, judges will have like 5 and 10 minutes to continue to talk to the team, and you guys will be part of that Q&A. So teams, be prepared. Sorry, I just busted some on you, but good luck. They can ask any questions, so if you don't know, it's okay. But yeah. So presentation. So can we have first team up, Ryan Sharp's team?
Go ahead and connect this.
Be energetic. Think of it like a Red Bull. You guys got it. Be happy. Okay. Good luck to every other team.
Wait, are you on the stream yet?
Not yet.
Oh, it's stream. Turn on stream. Go for it. And then go ahead and share your screen. Sorry, my bad.
If you don't have a presentation with technical difficulties, this is a good presentation.
Okay. Can you go ahead and mute your? There we go. Let's mute that. Okay. See if this works. All right, cool. We're good. Yeah, just gonna try.
Oh yeah, y'all turn your readers off. So I can say that, but it's okay. I can change that. Once it's there. It's okay. You focus on the project at least, right? Yeah, not stressed off. Yes, absolutely. Let's go.
Hello guys, our project is called Emotion. I'm Aaron.
I'm Chris.
I'm Abhishek.
I'm Jesse.
I'm Alshita.
And I'm Jamin.
And I'm Ryan.
Wow, I love emotions. Quick question, everyone. Who here has a face?
Hey, yo, me.
If you don't have a face, that's a really big problem. All faces, happy or sad, are wonderful. That's why after looking through hundreds and hundreds of photos, we created a neural network that recognizes 7 facial expressions. Our facial expressions are anger, disgust, fear, happiness, sadness, surprise, and neutral. The problem is sometimes it's hard to read crowds. Emotions are important because we need to interpret, build characterization, and ultimately describe who we are. Our solution to that is to run a model that accurately describes emotion recognition. Our motivation for this project, we wanted to learn about CNN, or convolutional neural networks. Neural networks allow to interpret pixel data, run a model, and then classify facial expressions, we want to use AWS SageMaker as well. SageMaker provides very elaborate, high-end, end-to-end model solutions that allow for data tuning, data labeling, and hyper tuning. We also want to use the front end and AWS together. Our front end, we split our group into two teams, which is a front end team and AWS. Front end uses Flask, which is the actual picture itself, and our AWS runs the model.
So let's get to talk about the model. So before we get into it, it's pretty important to talk about the data set because good data makes a good model. So the data set that we got was from a Kaggle data set. It had multi-class labels. So that means when we scrape the pictures, we had the pictures clean and labeled into the emotions like anger, disgust, fear. After taking those pictures, we normalized them, basically making those pictures into a value between 0 and 1. And we packaged them into images of size 48 by 48 into batches of size 64. So after we got the Kaggle data set, using the Kaggle interface, we were able to import that into AWS S3 bucket. So now we have all the data onto the cloud. And then using the AWS interface, we were able to import the bucket data onto the SageMaker so we could do our model and our testing.
So for our project, we decided to use a convolutional neural network. And so we decided to use this neural network specifically because it excels at image classification tasks and object recognition tasks. And the reason it's so good at doing these is because it was actually developed and kind of based on the human visual cortex, which is kind of what gives it that kind of adaptability. And so one of the neat things that it uses from the human visual cortex is something called a local receptive field. So instead of having to download this entire image and make each individual pixel a node in your input layer, it instead is able to use local receptive fields, which kind of help reduce the inefficiency and bloatedness that some models get. And so real quickly, how this model learns, the first thing that it does is it uses what are called filters. And filters just emphasize certain features within the images. So you can see there that when you apply a vertical filter, the vertical white lines and the vertical black lines kind of get emphasized. When you use a horizontal filter, the horizontal white lines kind of get emphasized. And so higher level layers in the CNN are able to build up on the features found in previous layers. So we can see here that we first found vertical and horizontal lines, but higher layers are able to build onto that by finding more complex shapes like those triangles or those sideways keys or those crosses. And then even higher layers are able to find more novel patterns like fish or houses or even CNNs that can identify like certain species of like dogs now, which is just pretty amazing. And so along the way, pooling layers are going to decrease the image quality. And this is going to help because it allows there to be more breadth when looking for more novel characteristics, because you can't exactly look for like 128 species of dogs or 128 features if you're still using 48 by 48 pixel images. It's just going to take too long. So pooling layers decrease the image quality, and then the model is flattened and put into a normal neural network where predictions can be made. And so specifically for our project, how we did it, we decided to build it on the AWS cloud using the AWS SageMaker that Abhishek talked about. And so this was done using a virtual Jupyter notebook. And we decided to use TensorFlow, which is an open source package available through Google that allows users to design and implement their own machine learning models. And so more specifically, we have 4 convolutional layers, 64, 128, 512, and 512 nodes within there. And we also had 2 dense layers afterwards, which had those features fed into them, and the predictions were made based off of that.
We wanted to have the best possible structure for our new neural network. In order to do this, we wanted to be implemented hyperparameter tuning using the Curious Tuner Python library. The main parameters that we tuned were the dropout %, which removes excess nodes in order to counteract overfitting, the number of filters on the 3rd and 4th convolutional 2D layers, in order, and that is the amount of nodes on the image processing layers, and the number of units on the dense layers, which is the number of nodes on the flattened image layers. Since our model was so big, it took a lot of processing time. to run it. So in order for us to run it, we have to use a virtual computer on the cloud using the AWS EC2. But the AWS EC2 storage wasn't big enough to hold our data set, so we weren't able to run the hyperparameter tuning. Although once we're able to contact AWS to increase our storage, we'll be able to run our tuning program.
All right, so the question is, how well did our model perform? The answer is pretty good. On our confusion matrix, which illustrates how well our model performed, the far left is the actual value, the bottom is the predicted. Our model is very good at predicting happy. When it predicted happy, it was actually happy 86% of the time. Our model, unfortunately, wasn't that good at fear. It would often predict it to be sad when it was actually fear. So that's how our model performed. Very good on most of them. Let's compare that to the best emotion detector in the world, the human. Humans often have a 72% emotion recognition accuracy, and our model had 65% accuracy. So we did very, very well. We can improve this number upwards of like 5% with hyperparameter tuning. And now on to our demo process.
Now for the fun part, we'll be doing a live demo of our product. So as you can see here, Ryan's really excited about our presentation today. So this tool can be very helpful. For example, if you're practicing for a presentation, you're able to gauge what your emotions are and areas of improvement, as well as how your audience feels towards your presentation, so you can make improvements beforehand. We will now pass around you guys can go ahead and test out our application as well. We'll go ahead and pass that around for all of you. Okay, awesome. Now let's talk about the process and what just happened. So using OpenCV, we were able to identify the webcam and use live footage in order to identify the user's face. And using OpenCV again, we were able to draw a bounding box around the identified face. Using the model, we were able to predict the emotion that the identified face was feeling at the moment, and the output would be the emotion, which is displayed on the top of that bounding box that you just saw.
So part of the process of the model that you're seeing here is using each of those endpoints. So after we created a model on the SageMaker using Keras and TensorFlow, we were able to deploy on the endpoints. Unfortunately, however, we ran into technical difficulties in using the endpoint to pass in the images and predict. Our initial architecture was to use the front end and use an API call to use the endpoint, but in the end, that just turned out to be too much for what we could handle. So, but in the end, we were able to successfully deploy it and have it up and running.
Let's talk about the future of our front-end application. We hope to switch from Flask, which is currently what we're using for the application that you'll see, to React, because we want to make sure we build an interactive user interface for all of our users and improve our design. React is also widely used in many tech stacks among several companies. So if we want to take our project to the next step and make it more widely used and create more developers, we want to ensure that we're using developer-friendly tech stacks. React has also increased flexibility and performance, and as you can see, we started our React app. This is our progress so far. We have a landing page, login, and you're able to then create a new call. This uses TensorFlow and React. Our main improvement using React would be the dynamic analytics that the user would be able to gauge what kinds of emotions they're feeling and what kind of emotions their audience is feeling. For example, when I was practicing this presentation, I was feeling pretty happy about our performance today, so I could gauge that I was feeling happy at the moment. We were able to then give suggested improvements on the current emotion and also the different emotions that I was feeling alongside the presentation. So if there was an audience and they were feeling angry, you would be able to gauge this using the pie chart here, and you'd be able to make improvements for the final round of presentations.
So some more future improvements that we can do for our project is include more analytics for the users, like the pie chart you mentioned, as well as make emotion detection more accurate, improve the 65% in the upwards range, and improve our data set, possibly appending more images or using a different data set or combining data sets to increase diversity and balance our emotions.
That's it. Thank you.
Thank you.
We're now open it to questions.
So you all freshmen?
Yeah. I'm a freshman and Jesse is a freshman.
Okay, everybody else is with some. Stop. Looking at okay. Cool project.
Thank you. Yes, sir.
So, when I use the demo, I have a really hard time getting it to say anything other than sad. I was wondering if you had insights about that.
Yes, so one of the things that was touched on here was the quality of a data set. So the cattle data set, when you kind of examine it, it kind of has clean faces with no facial hair or anything. It's just kind of like babies or whatnot, or just like shaving males and whatnot. So it's very clear images. So it's not able to pick up more complex faces like yours. So so that's why it was predicting different emotions than what you were probably feeling.
Yeah, and that kind of ties into the last point that Chris was talking about. We need to increase the diversity of the data set too. We've also noticed that it performs, well, the data set was primarily made up of Caucasian males. So increasing the diversity of that will mean that it's going to work better on other people who aren't just Caucasian males too.
Right.
How do you see this technology being used in the real world?
Well, a good example of that would be right now. So if we say this was a practice round for this presentation, our future goal is to be able to have the camera facing our audience and be able to detect all of your faces and the emotions you're feeling. We can then go ahead and take the analysis and the data visualizations that we had up, such as the pie chart, to then examine those and see areas of improvement for the speakers. So that would be one of the use cases that we would build towards.
Yeah, tagging on to that, we were also thinking about Microsoft Teams calls and Zoom calls. We'd also like to find metrics that kind of measure attentiveness. So that way teachers could probably use it to gauge student attentiveness while they teach as well.
Okay, so firstly, great job. I really love the project, and back in my engineering days, I had done an image processing project, so I can relate to the difficulties that you must have faced when it comes to cleaning an image. So my very first question is, how did you clean images? What kind of image processing techniques did you apply? That's my first question. Which I think you said that you had clean images, but if you were supposed to do that, how would you go about doing that? That's my first question. Second question is, every model has got a lot of features. So how did you decide on the importance of features? It's not always that we need all the features that should go to the neural network, right? So my second question is, how did you know the importance of features? And my third question is your model gonna handle mixed emotions? So like sometimes, I cry and I smile. So that's some mixed emotions. So can your model handle that?
Yes, so I'll start with the third question there first. Yeah. So for the mixed emotions, so one of the flaws of our current model is that the way the data that we have and the ranges of emotions that we have is imbalanced. So happiness and sadness, because they're the most clear to see, we have the most examples of that. But shock, disgust, fear, we have very low examples compared to the happy. So we have emotional imbalances in our data set, which means that when we're showing it and we're trying to predict mixed emotions, maybe it's not able to do it to the best of ability. So to be able to handle that, we would firstly improve the imbalancing and then try to see if the model, just by correcting the imbalance, maybe it can better its performance. And if not, we can research from there. The second question, or the first question of how to clean the images, right? The pre-processing. So the pre-processing that we did, we ran it through an image data generator by TensorFlow, which automatically composed into the small 48 by 40 pixels. We also ran the images through a grayscale to try to take out the effects of color in our images, so it could be more fair. With more images that are more fuzzy, beards, and they're more difficult to analyze. I think the first step would definitely be to find quality and clean images and try to get a best representation of what a best representation of a man with a beard looks like, or the best representation of what a crying face with happiness looks like. I forgot your second question, sorry.
Yeah, so my second question is how did you gauge the importance of features? Did you
Right.
pass on all the features or did you pass some features?
Right, so since for a lot of us, this was our first time working with CNNs, we pass in the entire image as it is into the thing. And this also works with our data set because the data set was just profile photos, so it was very close-up shots. So even if we did pass in all the images, it was passing on the important ones. So obviously if we would have more complex images, like an image of an audience where you have chairs and all these different things, we would have to look into how do we get to section off each and every person from all these different features. So yeah.
All right, I'll go next. So first of all, good presentation. So I co-teach the startup launch class over in the entrepreneurship department, and you guys speak better than some of them, so good job.
Thank you.
This is just a really random question out of curiosity, but why do you think the model is more inaccurate with fear and anger?
I think it's just because we don't have enough data for fear and anger, because our model was mostly made up of happy and surprise. So because of that, I don't have enough data to change off fear.
Yeah. I think we had like several thousand pictures of happy faces, but only a couple hundred pictures of fear and disgust.
And just in addition to the fear and anger, I think the nature of the emotion is such that a fearful emotion can turn to anger, and then the angry emotion can turn to a fear emotion. So I think that's like the transition that you can easily go from fearing something to be angry is just so fluid, and I think that at least for this model, it just wasn't able to take that up just because of the limitation of our knowledge of modeling as well. So yeah, got it.
To tag along, to get further insight on our data set itself, happiness was roughly around 7,000 images. Everything else was roughly around 4,000. And like disgust was very on the low end of like 400. So there is a lot of imbalances in that. Yeah, that's amazing.
So then, like, what's next? I know you went over like if you were to continue building it, what you might add, but like, is there a future? Like, are you gonna keep working on this, or?
We hope to keep working on it in the future. We're actually making plans to continue developing it over the summer to become a larger scale project, such as what I described with being able to gauge the emotions of an audience or on a Microsoft Teams call.
Yeah, our initial kind of plan for this project was to be a fully functional almost website where we would have like a website you would log into, right? And you would start your mock presentation or whatnot. And then the front end would send, it would like, we would use OpenCV to take screenshots every minute or whatnot just to get a basis of what you look like. And then we would send those images to the back end. It would predict and it would just keep giving you through that connection output of what your server is, and you would have a dynamic graph. So that was our initial vision, and so we hope to construct that and just make that a reality.
So I'm gonna cut everybody off a little bit. We're trying to get through our teams. It looks like I let it go on a little bit too long. There's a demo you can try out. We'll give it to the judges. Finish up the presentation real quick.
Yeah, we're just taking questions. Yeah, we were done.
Oh, okay. Then yeah. Then go to the thing or something.
Yeah. Oh, I guess.
But thank you, everybody.
Thank you.
So I can just plug this in here, yeah?
Let's go, David.
You blocked it now. Okay. There you go.
Okay. Project, blah, blah, blah. Emotions, finesse.
I think it's. Can you share your screen? Yep. And then just share screen. Share that our Chrome tab. I your presentation.
Oh, it's a Microsoft.
Okay, then share your Windows. I think.
There we go.
There we go. Sweet. Awesome.
Yeah. All right. Do I still have control in here?
Yeah, you guys control. So yeah, you're all set on the stream. Thanks so much. Time it and then cut it off.
I literally slide just want to know how.
Here's yours.
Yes.
Yes. Yeah, Thomas, they're all taking pictures of the screen. Who are they your friends?
Yeah, they are.
Okay, you have a lot of friends.
Let's go.
All right, let's get started. So our project is the real-time ASL translator. My name is Thomas Metz.
I'm Dan.
I'm David.
I'm Sina.
And our mentor, Abhirami, is over there. So for the overview, so our motivation is to learn and explore neural network by implementing real world object, which is ASL, which is really real. Everyone, like about 1 million people using it right now, and we try to detect them and classify them using AI. And our is using a deep learning classification model. So our approach for this is we classify every image, every data set, available data set, and then we will transfer learning. We will train the model so it can know what to recognize, and then it will learn on different data sets, not just one data set, but different multiple data sets.
All right, so we faced a few challenges during our project, and one of the biggest challenges arose from the nature of our data. So we wanted to make a live ASL translator, which means that we need video input data. So our data set was approximately 17,000 files, and the pre-processing on video data is inherently a little bit more complicated than image data. So the way that a video works, we can't just feed the entire video into the neural network. We have to split it into images and then feed groups of those images into the neural network. Another difficulty that we faced was that our data set had around 2,000 classes, but it only had 17,000 videos. This meant that we had, on average, 7 to 9 videos per each hand signal. This made it difficult for our model to predict as accurately as we would have liked. Another difficulty that we faced was with the resources required with such a large data set. So we had to change our model quite a few times. Originally, we started with a VGG16 model, but we found that this model was too old and too slow. So we had to switch to a smaller, more lightweight MobileNet V2 model. Once we got to the implementation stage, we had to split our data into a number of batches in order to train it in an efficient manner, in a time-efficient manner. So once we got all of that done, we faced another challenge with our front-end integration. So we ended up training our model on AWS EC2 using Python. However, to implement our model, we wanted to use JavaScript so that we could create a React app. However, in the conversion process, we realized that there were a few variables that we had to specify on the back end in order to convert correctly. So we had some difficulty creating a web app, but we did finally create a user interactive environment. And the final challenge that we faced was just getting accustomed to the cloud environment. This was not something we had ever used before, so there was a big learning curve.
Okay, so first we had to prepare our data. So the data set was a JSON with a lot of video URLs along with descriptions like what class it was. So the first thing we did was we downloaded all those videos and put them in an S3 bucket. And then from those the videos in the S3 bucket, we generated images from those videos, taking them frame by frame, and labeled them with their correct class. So one challenge was getting the data from S3 to a local EC2 environment without accidentally deleting all our data and setting our project back by 2 days. So then we had to take those images and put them into batches, meeting certain constraints. So you cannot have 20 of one class and 0 of another class inside a batch. And then what we did was the actual learning on those batches was transfer learning. So transfer learning, the idea is you take a pre-existing model, you chop off the last layer in the hope that the model has learned some features, and then you attach your own layers to those features, which you will then use on your own data set. So we originally wanted to do VGG16, that was in the original code, but once we fed a lot of images into it, even if everything fit in memory, running VGG16 was very, very slow. So instead we switched to a mobile net, which is a very lightweight network. It's supposed to work on a mobile device. That's where the name comes from. And it was much faster, and it's still a very, very good network. And this also helps the front end, because the front end has to run in a reasonable amount of time. And then we batch trained the model with the images. So if we train all the images once, we would run out of memory, or we'd have to get an EC2 instance with a lot of memory, and we didn't have the funds for that. And then finally, last but not least, there is deployment, where we wanted to create a user interface where you as a user turn on your camera and you make signs, and it will caption your signs. It'll say this sign is book, or hello, or any other sign in our list of authentic words. So this is a visualization of what it looks like. So there we have a video. We take frames from that video, we feed it into our mobile net. We get a 1280 by 7 by 7 tensor, which we then flatten and feed through our own fully connected layers. And then we plug it into the softmax function, so we get probabilities for every class label. And then out of those probabilities, we take the max, and we say, this is the book.
So we do have a live demonstration. Hopefully this will play. Yeah, so you can see that Dan is able to sign at the camera, and it will actually predict the signs that he is using. We are looking to deploy this as an actual web app. Like I said, there was a small issue that we faced on the back end that prevented us from integrating this as a web app. But in the future, with more time, we can easily fix that issue. And we have all of the architecture in place, so we can already implement that once we fix that.
So given the use case and our target to classify 1,000+ class labels, we are only halfway through in this time of 10 weeks. Our plan for the future includes translating entire sentences as the signer continues to interact with the webcam, exploring on adding this as a caption option in online streaming videos such as YouTube, working with other models like i3D and perform hyper-tuning to achieve better performance, improve the front end to enhance users' interaction and experience, and also collect more data to support classifying 1,000+ signs.
Thank you.
Just a notice for the judges.
questions. We were trying to keep questions to like 5 minutes. So if like you just have one or two questions, you can just ask the team. That'd be great. Thank you.
So are there similar tools that you've seen other people have built? I mean, this would be something that, right?
Yeah, there are some tools already built, but like, it's like we are very kind of new, so we try to learn how to create the tool. So we rather than
awesome.
Do we have a question?
What's the accuracy for your classification?
Well, we due to the time constraints, we didn't really have the time to properly test the accuracy. So we're afraid that it overfitted on some of our on some of the images because we were taking multiple frames from the same video. So we're worried that it spent more time learning features of the video other than the size. But yeah, that's if we had more time, we would test it more accurately on a good validation data set.
One of the other features that I'd like to highlight is our data set. It's called the WLASL data set, and it has about 2,000 signs in the set and only about 17,000 videos. So I mentioned before, that's not many videos per sign. So it does lead to the issue, like David mentioned, where a model has a tendency to overfit based on what's actually in the data as opposed to the hand sign that's being used. So if we were to optimize this in the future, expanding our data set would be very valuable to increasing accuracy.
Or just take a subset of those classes that have a lot of tables and forget about the remaining 1,900 symbols, which is basically what we did.
You mentioned some resource constraints. I wasn't exactly clear if that's both a data and a processing thing or both. But how much does that set it back? Is this a matter of you just need to keep processing the data for a few extra weeks than you prefer, or is this like you would ideally have some additional amount of funding to overcome the obstacle, if that makes sense?
Yeah, so I'm like the one that babysitting the train when we train it, and it's always like I think I can count like 5 times it froze on me, and I have to restart the training like all over again a bit and increasing the computing power. But like it's just keep doing it. So you have to like then we have to like split the batches. We have to train like batch by batch, like 4 batch each, and it's like and the accuracy like after each batch is kind of like low, a bit low too. So if computing power is my work.
Well, what I'd say is I think each batch had about, correct me if I'm wrong, like 15,000 images. I think that was something in that range. So if we could add more, but then we'd run into memory issues.
I think 1,500. Each batch is 15,000.
The right number of zeros.
Yeah.
But theoretically, with the right amount of computational power, we could run it on the entire data set.
But it's not such a big deal. You just run it 4 times instead of running it all. Yeah.
So for the memory issue that you just said, did you try to remove the redundant frames, or did you pass on the entire video in as frame? Because every frame there can be repetitive frames, right? So did you remove those frames?
Yeah, so we did try to, so like every video is about like 30 FPS frame per second. So we did try to remove like every other frame.
Every alternate frame.
Like every other frame, like
Yeah.
like remove like all the odd frames or like all the even frames.
Maybe to address the issue that you said, you can try to see and ensure that every frame is different rather than giving redundant frames. That may help you.
Thank you for that.
It was a balance between having too few frames for training purposes and having too many frames for something that could be redundant.
Yes.
And I'm sure you did other AI projects, and this is just one of many AI projects. Out of all the AI projects, do you see the one that's driven more from a time-related sequence AI? Is that more challenging or more demanding than a straightforward machine learning AI project for you?
I would say that it definitely adds another aspect that proves difficult. I did a lot with the front end implementation. And one of the things with live video is it can be difficult to get the server to interact the way that you want with the live video data so that you can get the prediction that your model is made to use.
Yeah, I think it's the data set. I mean, your accuracy, much greatly improved with the data set, and obvious data set source is probably YouTube. You go to YouTube, they got the CC translation, so you got all the information you get right there. So that's it.
I think our data set actually correctly labeled. We actually go through and check all the data set before we use them. It's actually correctly labeled. Everything is correctly labeled. It's just like, I think our model learning the wrong thing on the video instead of like the sign of the feed, like the hand sign.
Yeah.
Okay, so I think that's it for questions. Thank you so much for.
Yeah, you disconnect. What's that? Yeah, just disconnect yourself from the stream. Yeah.
Thank you.
Let's see, right?
Working. Where's the HDMI cable? I need a USB-C cable. HDMI. Right here.
Oh, okay. Did you go and share your screen on the stream?
Yeah, so where is it?
Stream link?
Yeah, so there.
Go and share.
Share screen.
And is it a Chrome tab or a window?
It's a Brave, so it's Chrome here.
There you go.
Sure.
Wait, hold on 1 second. Sorry. Good to go.
And that's our presentation. All right, so I'm gonna get started then. Our project is called Ingenuity. It's a search engine for GitHub's discussion boards. My name's Keisha.
I'm Sharuk.
I'm Varsha,
I'm Yusuf. And I'm Sarab.
and this is our mentor, Rami.
All right, so I have a question for y'all. Have you ever been confused while using open source libraries while coding? Okay. Yeah, us too, all right? So again, another question. Have you ever tried looking through unintuitive documentation? Like what's pictured on the screen right now? Well, we have, and we consider it a torture. All right, so from this, we identified our problem. So it's that open source libraries are confusing with convoluted documentation. And that these days, even though there are resources like GitHub that provide source code and documentation for people all around the world to read, that oftentimes their issues and discussions are still a mess. And GitHub discussions is going to be our focus for the remainder of this presentation. All right, so now onto our solution. Basically, what we realized is that nowadays, search engines are mainly powered by machine learning. And so we decided to develop our own model that will help find the solutions to these problems. And so, for example, people use stuff like GitHub's discussion board in order to find the answers to problems. But oftentimes, even the most common problems, it's difficult to find an answer for. And even once you've found an article, it's difficult to see which answer is the best. That's why we're going to use multi-label classification in order to find the correct article, and we're going to be able to identify the best answer provided using a question and answer pipeline.
All right, so let's take a look at how we got our data through our data flow. So obviously we use first of all, we use the GitHub REST API to get all of our discussions. And we also use GraphQL to get the issues from GitHub as well. So once we have all the data, we put it into an Amazon S3 bucket, and from there on, we put it into SageMaker as well as eventually going to deploy it onto the cloud. So once we have the data, it's very important to pre-process. And the reason why is because with NLP tasks such as this, obviously computers cannot just read English language. So that's why we use both one-hot encoding and tokenizing to make sure that the computer can read it. So let's start with one-hot encoding. So what happens is every word or every subsequence of words or symbol is given either a 1 or 0 depending on where it is in the sentence. So for example, if the word is John ate an apple, the word John would be given the vector 1, 0, 0, 0 because it is the first word in that sentence. In addition to that, we're also going to be tokenizing, which basically just gives a number to all the words in the data set. And that also lets the computer read the data set very well. So once we have the data out of the way, I'll give you a quick model overview before we get into the nitty-gritty. So what makes our model unique is that we mainly use 3 different techniques. First is data augmentation, second is multi-label classification, and third is neuro-semantic search. So let's take a quick peek into our tech stack, and my teammates will go more into detail, but let's start with PyTorch. PyTorch is the main deep learning framework that we use, and that's where we build our neural networks. That's where we do most of our hard coding. Timecode is where we use something called a vector database, and that's very important for the neuro-semantic search part. This little logo over here is the GraphQL, which, as I already mentioned, is how we got all of our GitHub issues. Python is Python, and weights and biases is a very powerful tool that we use to track our model over time. And finally, the most important of all is Hugging Faces, which is a company that provides something called a sentence transformer, which is super, super critical for our model. So let's begin with data augmentation, which is just a bit of further pre-processing, but it's super crucial. And the reason why is because what we're essentially doing is using the data we already have, changing it up a little bit, and adding it back into our data set. Why is that good? And it's good because at least things like this. So we have the sentence, this is very cool. And through augmentation, we can get this is pretty cool, this is really cool, et cetera, et cetera. And the reason why this is good is because a normal lexical search will not be able to realize that this is very cool is the same as this is kind of cool or this is very cool. So this makes our model more robust, and this makes it perform better. And synonyms aren't the only thing that you can do. For example, over here, you can see that other augmentation techniques such as insertion and substitution are possible. So we have the quick brown fox jumps over the lazy dog. Through substitution could become the easy brown fox jumps around the lazy dog.
So you're probably wondering what multi-label classification is and how this can help us with the project. And so our goal for this is to be able to read a post in a forum, such as on GitHub or Stack Overflow, and through our model, be able to determine what labels or categories that question or query belongs to. So if you were to post something like, how can I solve this issue in my code? The model would probably be able to classify it as a bug, a question, and anything else relating to that. And for this, we use the BERT model. The difference between the BERT model and others is that rather than just looking at the text from left to right or right to left to determine the context of the words, it uses bidirectional, it goes bidirectional, and this helps it give more depth and accuracy to the context of the words and helps it with stuff such as masking, where you change a word, you take out a word in the middle of a sentence, and the BERT model can actually determine what that word is using bidirectional flow. And this model was actually recently created in 2018, so it's very new. And it can be used for stuff such as next sentence classification, masking, and much more. So BERT uses transformers. And what transformers do is they determine the contextual relationship of the words. And so they take in a sequence of tokens, which were originally the query, the question, and then they embed them into vectors and put them through the layer. And it maps the sequence of vectors with built-in labels. And once it has the outputs, which are going to be the labels that the model is most sure about, that the query belongs to, it then puts them into another classification layer using the Gaussian cumulative distribution function. And what this function does is it helps further specify the data and make it more accurate. You need this when you have a wide range of data, or a wide range of possibilities that you're not sure which label it belongs to. And it's multi-label classification, but you don't want too many labels on the one query. And this just helps center the results and helps accuracy of the model.
So now I'm going to talk about the question answer model that we created. So our question answer model, it aims to extract an answer given some context. So like Sharuk said, we used our GitHub GraphQL API to retrieve all of our data. So it's a very, very neat interface and it's very user-friendly. So using that, you can get like almost everything you want from GitHub. Like when a discussion is created, the URL for like a GitHub discussion, the question, the answer, the context, things like that. So we didn't use all the attributes that the API like gave us. We just needed 3 things: the question, the answer, and the context. So using that, we vectorized the GitHub discussions using a small model from Hugging Face, which is the application we use the most throughout our project. And we also used sentence transformers from Hugging Face to verify the similarity between the question and the context of the answer. And this used cosine similarity. So like Mark said before, we're using Pinecone, and this is what we use to create our vector database. So looking at this diagram, it basically, we give it a question, and then it converts that query into a vector, and then it puts it into our database, and it starts comparing 2 vectors to see how similar they are with each other. So we also use neural semantic search in our model, and it's a very complex process, and it was like fully developed in either 2018 or 2019, so it's very new as well. So in short, it's a deep neural network powered information retrieval system, and the search runs through a neural network that encodes the query as a high dimensional vector. So this is different from like a regular lexical search, because in a regular lexical search, we're like comparing a query with a database. But for this one, we're going through a neural network, we're passing in those context vectors, and we're like comparing it a lot so that it can get the best semantic value. And semantic means like meaning.
Okay, so let's do a demo of our 2 models. Just to recap, we have our multi-label classification model, and we have our neural semantic search model.
Okay, so this is so it's 4. There.
So let's start with our multi-label classification model. And let's say I'm in a forum, I'm running into issues with my code, or I just have a general question. And so let's write a question such as, CUDA ran out of memory. What should I do? As you can see, this model classifies it as a question and also a bug, because the CUDA is an error in GPU memory. And also classifies as a docs. This might just be a inaccuracy in our model. And so let's go to the semantic search demo. And let's say something, what question would we want answered? We'd want to ask maybe, what are callbacks in PyTorch? My bad. In PyTorch Lightning. And here it would give an answer that roughly describes
and answers our question just through the neural semantic search.
All right, so to reiterate about weights and biases, it's actually it's a pretty popular MLOps tool used in the industry today, and we use it throughout our project just to see how our models compare. So let's look at the validation. So the validation part of any ML project is to see how well your model does. So as you can see here, our model hovers around 0.4, 0.3, around there. And then before you tell me, wait, that sucks, 0.4, 0.3, 1, it's not even good. The thing is, it's actually pretty decent because if you just look through any GitHub issue or discussion, it's just a bunch of code, coding snippets and a bunch of random even text numbers. So the fact that we even got to around 0.3 and 0.4 is actually pretty good.
All right, so what can this model be used for, right? We're not just creating this model just to say we made a model. We want it to have some purpose. So some applications of this model not only can be used on GitHub issues and discussions, but with the right data, it can be used on other discussion boards such as Stack Overflow, educational forums, and really any question and answer forum in need of a better search engine. And then here's some future stuff. So one future step is user experience. As you can see, our front end is very bare bones, and it kind of just gives labels or it gives one single answer to a question. So future development could be using React as our front end, which is a very industry relevant framework, and also providing more options for the user to view rather than just the labels and maybe one answer. Another thing is we could have had better data. Number of GitHub issues are limited due to the amount of storage that we had. So if we had more storage, we could use more data. And then we can also expand on this in future implementations. Another thing that we can do is we can make sure that we're validating data from GitHub, because there are issues and discussions that are sometimes wrongly labeled to begin with. So being able to tell if it's wrongly labeled helps a lot as well. Streamline search, so giving the ability for the user to augment their search with keywords or additional inputs. That way we can have them, as the example says, the ability to search a specific repo, user, or organization, their discussions. And then another one is a standardized evaluation. So measuring the quality of our search results to highlight the efficacy of our model. And that's the end of our presentation.
Oh, yes.
Hey, good presentation. I just might sound the dummy on me, but I just want to understand the product that you built. And from what I understand, you have some type of product that scans a website and then feeds it to some type of brain. And then a human being like me can go onto a web page or an app or whatever, ask a question in human-like form, and then the brain will reply back with a great answer based upon scanning the website. Is that what your product is?
Pretty much, yeah, exactly.
Awesome, awesome. Because something useful for this type of product could be like a customer support, you know?
Oh, yeah.
So does your model handle spelling mistakes? That's my first question, because I saw that you actually corrected the spelling. So I assume that it does not handle spelling mistakes?
I can talk about that. So regarding our data augmentation, that's exactly one of the things we did. We did something called I don't remember the exact term, but it basically sees how far away from the keyboard the letters are. So it can actually augment the data sets, like you saw where it changed this is very cool to this is pretty cool and whatnot. So it can actually change let's say cool. It can change to COWL or whatever letters are nearby, and then it accounts for that. And also just accounts for random errors, it'll randomly substitute one letter, randomly delete one letter, and add that back to the data set as well. So it does account for spelling errors to an extent.
And one more question, does it handle grammatical errors? For example, if I say I am studying at UTD, and I change the grammar saying studying I am at UTD, which is grammatically wrong, but we understand the meaning, we as humans understand the meaning of it, right? So does your model handle such situations?
Yeah, it should be able to do that. What it focuses on mainly is the keywords and tries to find the most important words that match in other form queries.
Okay.
And so the reason I corrected my spelling mistakes and made sure it's grammatically correct was for the sake of the demo, but it would probably be able to classify it decently accurately.
Great job.
What was your biggest challenge and how do you overcome it?
So we had a lot of challenges. There were a few problems when we tried to use pandas in our model. There were also problems with just the amount of data we had. We had problems with batch sizes. I don't know if any of these problems was more severe than the other. But one of the biggest problems that we had in one implementation of the model was we were using the BERT model, but there was some parameter that just was failing every time for some reason. And even after cleaning the data and doing everything, that one parameter was still failing. So, I mean, that was a pretty big problem that we had.
Yeah, the model was very sensitive, so it seemed like you fix one thing, but it creates an error in another part of the model. And so eventually we were able to figure it out and get it right, but the model was definitely training the model was definitely the hardest part of this.
I think the other question, do you still?
So according to your demo, it seems like your model returns multiple answers to your question. Is that correct?
Right now it's just one. We just choose the top answer, but we could probably make it so like it sorts it by best answer, second answer, just like a normal search engine.
Yeah, and that was in our future developments as well, is just rating those answers from best to worst using that algorithm. So.
Okay, thank you so much. We'll go to the next one. Oh yeah, check out Slack if you're I'm about to send it.
It's Google Slides, right?
Yeah.
Yeah, you just do a Chrome tab.
But the demo will be also.
Oh, there's the window, yeah, the window, that's fine. Yeah, you can just go to your slides. Yeah, you guys are good to go. You can just click hide on that.
Hello, we're team 2, and I'm Kapish. I'm Vivek.
I'm Aruna. And this is Mathematical.
Hello.
So our project is called the Auto Commentator. So with the use of smartphones, the interaction of audience with many industries has become faster. And so with the sports industry, that all these sports companies can now interact with their audience even if the audience are not present at a stadium. So we focused on making the interaction smoother. So for that, we created a sports commentary generator, which takes an input of a real-time video, and then it generates commentary about the actions of the players as the output. So it's basically for all the sports fans out there who love watching sports, but then due to various situations in life, they cannot always spend the time to watch the video in its entirety. So for that, we generate comments for each player's movement, which gives a description of what they're doing. This saves a lot of time for the audience, as they don't have to always keep watching the video or have to watch the video at all. And they can be doing some other work in parallel and still be following the game. And this product is better than the sports commentators because generally commentators give their opinions and other external info while talking about the game. But this is purely action-based, so it only gives the required information about the actions and gives the users a better experience.
Yeah, so the data set we used was the multi-sports data set, and that has data from various sports such as volleyball, golf, basketball, and it provides like kind of like play-by-play data. And it's consisting of videos, and for each frame in the video, the data set has labels on what's going on in that frame. So for example, we chose basketball, and in this frame, it could be like a pickup ball, or like a three-point shot, or a dribbling. So yeah, this data set just has labels of what is happening in each frame. So to actually convert those labels into commentary, we need to do some data engineering, because you can't really just generate commentary if just like player dribbles ball or something. So to do that, we had about 18 different labels for basketball, and we generated some sample lines for each of those labels. So that was our data engineering of making some sample commentary that the model could then use to generate new commentary. And we also had to convert the videos into frames so that we would process them. And we saved and did all the processing on S3, and we also used SageMaker. And then for the model, we used SageMaker, and we used a pretty hefty model that we were only able to use thanks to cloud computing. There's no way we'd be able to run it on a local machine and get through all 20 gigs of the data set. And finally, we chose to deploy our demo using GitHub pages, since it was pretty simple. It was the simplest way.
All right, so to process the videos, we're using the CNN using BGG16. So this was the ideal model to use for this situation, since it's very powerful. It has 16 layers and 130 million plus parameters. So it's able to generate a lot of features for the model. So so after we extract all the frames from our videos, we feed it into the model after we reshaped it. And then after it runs through, we're able to extract all of the features from that model to use to predict the captions. So for the captions themselves, from the captions we created, we run them through long short-term memory, an LSTM, to sequentially generate the captions. So to do that, we first tokenize the sentences we created for the captions. So an example here, the player passes the ball. We first split them into individual tokens based on the words. And we drop any words that don't contribute to the meaning of the phrase. So in the end, the sentence will become player passes the ball because those are the most important words. So this is a diagram of the layers of our model. On the left is the LSTM, and on the right is the CNN. So after they finish processing, we combine them into one full model into BGG, and then that predicts the output based on the images that we give it. So in terms of model statistics, we used BLUE, which stands for bilingual evaluation. It's a bilingual evaluations scoring system. So it was originally designed to evaluate the accuracy of translations, but at its base, it can predict the accuracy of the predictions compared to the training data. So our accuracy on our first instance was 76.3%, which is basically considering the first few words of the predicted text. And when we evaluate the rest of it, it drops down to 66%. Generally, you don't want too high of a BLUE score because that indicates overfitting, since it's basically spitting out exactly what it was trained for. So these are generally pretty high. You want it to be around 50%. So there was a bit of overfitting, but it shouldn't be too bad. Now time for the demo.
If you want, you can scan it.
So if someone wants to scan, it's hosted on GitHub pages. You can scan the QR code. It will straight lead you to the website and you will be able to see the demo. If not, we'll just show it to you anyway. If you want, please try.
So for the demo, we weren't able to get like live inferencing done because our model is just kind of heavy, too heavy for like local inferencing. So we have some pre-selected demos, and if you click play, it'll play the video, and for each frame, display what the model is predicting for that frame. So for example, if you pause, you can see that for this particular frame, it produces player moves towards net. And that was like kind of one of our sample captions that we generated for player dribbling, like the player dribbling label. And ideally, we would have wanted to use some sort of basketball commentary data set. We couldn't find one, so we had to like make our own. So that's why the commentary isn't very exciting, but hopefully we can change that in the future, maybe find a data set or just make a better data set. Yeah, you can try the other two on your own.
These captions are also quite similar to our training ones, so you can see, you can infer how there's a bit of overfitting on the model.
And then for the future, we would like to expand this commentary generation to other sports, such as maybe football or volleyball. And we'd like to, or the actual data set that we used also contained bounding boxes, but we weren't able to get the network that could utilize those bounding boxes to work. So in the future, we would like to utilize those bounding boxes fully. And if we have bounding boxes, we can have additional data in the commentary, such as the players on the left side, or it's like this specific player. And we'd also like to fully implement real-time video captioning. Like we'd like to be able to, like ideally give a YouTube video and then it would generate it while the YouTube video is playing. But we couldn't get like cloud inferencing working, so yeah, that's the future. And that's all. Thank you.
So I think great project, amazing work. I just have like 2-3 feedbacks. Commentary is not just about player hitting the ball, you know, it's always the name.
Yeah.
Like Sachin Tendulkar hit the sixer, you know, things like that. So that is, I think, very important. I want to listen to the name of the players. Secondly, there are some rare events which happen on field, like records broken or player getting hit, you know, something like that. So I think that should also be included. Some rare events which have never happened before. So that would make it very interesting. And thirdly, whenever a player comes in, like for example cricket, when a player is actually coming into the field, the commentator usually talks about their history, their records, their overall, you know, performance. So I think you can try to include that part as well to make it more interesting.
Yeah, that would make it more interesting, but that's just not possible with the data set we use.
Yeah.
Since like the entire data set is just based on the player actions. So maybe if there's like another data set that could generate more exciting commentary, we'd definitely try to use it.
That would take, I mean, the main part is how to make it interesting and exciting enough, right? So it should perform better than human. That's what we are aiming for, right here. So.
Thank you.
So the commentary is coming out very fast, right? There's a way to smoothen it or maybe drop a few, because almost every frame is generating or every frame is.
So we are.
I mean, really can't even hear it that fast, right?
Yeah, it's actually, if you did it every frame, it's generating some of the same captions because frame by frame it's going to be pretty similar. But even with that, it's also going by pretty fast.
So we
you have to find a way to combine
several things. So the plan was that we have a delay of 2 seconds or 3 seconds, so we can have a more easier way to go through it. But with the model and GitHub pages, that couldn't just work. We couldn't find the way out.
The technology, is it visualizing the entire screen, or is it pinpointing where the action is and then focusing on that to do the translation?
Yeah, it's taking the entire frame of the video. Like we said, we would have liked to do it with bounding boxes because that would take out individual actions of the players, but we weren't able to make that work.
Yeah, and it's also, if you notice, there were like various different camera angles, so it also has to consider that, which makes it like a bit less accurate.
Okay, thank you so much for your questions there, everybody. Did you show the demo?
Yeah.
Okay. Did you take pictures of the demo? I was just bored. I'm like, let's add more Q. No, we're coming at you. Okay. I'll do a really quick extra. So thank you so much for sticking around. I know it's a really long time. Close my mic, okay. Thank you so much for our mentees and mentors for going through this. And thank you so much for watching it. So if you're interested in AIM, AIM mentee applications will open in the beginning of the fall semester of the fall. And so follow us on Instagram. Like, share, subscribe. Our Instagram is AIS UTD. Well, there's another AIS on campus, and then they copy us, but it's great, But let's see, AIS UTD, double check that. UTD AIS. That's what I thought. Yeah, you can't be showing the fake member, but so if you're interested in becoming a member or getting more involved with AIS, hit us with an email right there. And if you're interested in being a mentor, right there. And once again, thank you so much, Brian, everybody coming through. And thank you so much, everybody, for staying. I think that is it. Thank you. Those are our, it says everything. Okay. Dude, I was like dying. I can't stand it. That's a fuck homework for today. How'd you like them?
That was a great job. Thank you guys.
Yeah.
Thank you for coming over. Appreciate it. Awesome. There's
Okay, sounds good. Thank you so much for coming. I really appreciate it a lot. How was you thinking about overall that?
Overall, it was amazing. I mean, they're so innovative, so many different projects. It's great. So I saw everyone was focused much around image processing and video analytics. Was that the theme of this? Why not?
I think it's just more people just lean towards that topic.
Uh-huh.
Yeah, we're trying to expand to more different domains. I think a lot of our mentors were centered around certain fields. So that's what the project is.
I kind of keep because every project was related to image processing. But it was great. I liked it.
Thank you so much.
So we're trying to do each group individually real quick. Yeah. So everybody come down.
What do you think? Good job. Appreciate it. Yeah. Do you have any other feedback in terms of how it went well?
I mean, it's pretty straightforward format. Presentation. They were definitely overwhelmingly technical, which isn't surprising.
Okay.
I don't know if it's
yeah. Sure.
But yeah, how do you feel about it?
I feel good. I just I don't know if I want to break people absolutely know nothing about AI, it could feel a little intimidating just hearing these presentations, right? So that's something we keep in mind.
That's my fault. Are you talking about the entry level stuff?
Yeah, it just goes over your head and you're just like.
I would probably do it earlier. The event itself,
earlier time. Okay.
Because I don't know if the trigger when people come down was more because of the time or because they didn't understand anything they were doing.
I think it was just timing. A lot of people said they had commitments 9:30ish. So yeah, that's definitely logistics wise our fault.
No, I mean honestly the technique was better than I thought it would be.
Yeah, same honestly. Yeah.
So I was like, holy shit. So I mean,
Dude, I gotta invite you back, man. I feel so bad. I was just like, I gotta get our founder in our events more. I don't feel bad. Yeah, I just know our alumni connection has just been terrible, and I'm just like, where's our alumni list? And we don't have alumni list to contact. And I'm just like, we gotta make this. And so I think we had I saw you join our Discord server the other day, I think.
Yeah.
You are on there. We have a LinkedIn. I don't know if you're on that, a LinkedIn group.
I don't remember.
Don't remember. Okay, yeah. So we're just trying to figure out ways to connect with more alumni, invite them. I was just like, we definitely need you guys to come back. Because I feel like you guys are a really important part, vital part of AIS and how it grows.
I'm sure they would love being back. Everyone, most people we will take on, I mean, they're really passionate about the AIS one or the other. So
right.
I'm sure they would love it.
Yeah, for sure.
Yeah. Need help, whatever, just let me know.
Yeah, for sure, dude. I appreciate you coming on. We should talk sometime. Yeah. I just love hearing your stories of how the AI started. I just want to hear more of it because I literally do not know like how it even started in the first place. Yeah, I bet. So I definitely want to catch up sometime. Okay, sounds good. Yeah, sounds good. All right, talk to you later, dude.
Right there. So Jeep is right there, so face that way. Is everybody coming closer? Flash it. 1, 2, 3. AI is paid. Oh, coming closer. Oh, this is perfect. 1, 2. Yeah. Wow, look at this. 1, 2, 3. It's okay, no one else. No. I have 6.3 on my license. So, all right, cool. You guys want your teammates? Yeah, we did. Oh, you did? Okay. So, I'm playing with DJs or up to y'all. But it's like, I think we should do a big one where everybody's included. So, let's put off for now and see if we come to social on Thursday. Where it has to be your actual meeting. You have to go to an actual meeting. Just go to it.
It's from 7 to 9. You can join me.
You said you 7 to 9 also. Oh, that's not. Oh, we'll plan something big on the side.
Yeah.
We'll plan something official on our server. Is it actually your meeting? Yeah. Yeah, it's social on Thursday.
It's on our socials. We'll post it again.
Yeah.
7 to 9. Just drop it anytime.
Yeah.
Where will it be?
On Slack. On Slack.
Oh, where?
On Slack.
We're thinking TI auditorium, but that might change.
That might change.
That might change.
Are we in the TI auditorium? Yes, in TI.
So just the social. No free food, right? We're bringing food. What food?
Thanks, guys.
Yeah, of course. I think it's Chipotle. Yeah, it's Chipotle.
You don't think this is anymore.
Got it. Alright, well, you guys are really good. I was pretty impressed with like the project. Like first semester, like you guys did your gas. That's even more impressive. Like just the quality of the projects. So good job, guys. That's cool. I did not like it.
Youngest like saving that thing.
Sure. So you guys are doing that. I didn't know you were an aim. What the heck? I was just like, wait, that's true. I was already in wrong. That's insane. Yeah.